right, so let me get the notes posted. I did post videos and the notes from last week. I'm pretty confident I posted those, but I will double check. But anyway, we're still in section P5, which are rational expressions. And again, rational expressions, what I basically mean by that is a fraction of polynomials. You know, one polynomial divided by another. That's what I mean by that, a fraction of polynomials, okay? And you can simplify them just like you can write a fraction in lowest terms. We saw what it meant to simplify. Here's actually another example. Remember, to simplify means the only factors the numerator and denominator have in common are 1 and -1. And theoretically, you could factor top and bottom. But again, this example will illustrate that thanks to the factor theorem, we really don't have to do that. I mean, you can, but you really don't have to do that. All right. Now, so here we have x cubed plus x squared minus 2 times x, right? We're going to factor the top. And so right away, you can see that x, okay, is, you know, a factor, right? Because it's in every term. And in fact, the smallest power of x, the smallest exponent of x is is 1. So x we can factor out. And that's what we're doing here, right? You know, you put it in front. To get what's left over, you have to divide. And to divide means you divide into each term, okay? And so from here, we get x times, so you know when we divide, we have x cubed over x, that's just x squared, right? You subtract exponents. X squared over x is x, 2x over x is 2, like so. And so this is what we get. Okay, let's see if we can keep going, right? Because here we want to know if we can factor this. X squared plus x minus 2. Well, remember, that's a trinomial, meaning it's 3 terms. It's degree 2. Its leading coefficient is 1. So from here, we want 2 numbers then, whose product is -2. The sum is 1. And you can see from here, really, that 2 and -1 pull that off. Their product is -2, and the sum is 1. So 2 and -1 work. So from here, we're going to have this, x plus 2 times x minus 1. Okay, so when we substitute that, the top factored completely is x times x plus 2 times x minus 1. That's what we get. Okay, now we could factor the denominator. You know, we could do that, but in a sense, we really don't have to, because we could just use the factor theorem. Notice that the top, okay, the top from the factor theorem, it's enough to check if 0 is a factor, if -2 is a if 0 is a root of the denominator, -2 if that's a root, and if 1 is a root. You know, it's enough to do that by the factor theorem, right? So it's easy to see that 0 is not a factor, right? You know, it's easy to see that x is not a factor. You know, if you just plug in 0, you're going to get -8. That tells us x is not a factor of the denominator. I mean, you can really see that. You could have seen that also because there's a term with no x's in it. You know, if x was a factor, then you could factor it out of every term, but you can't do that. What about x plus 2? It's enough to check x if -2 is a root of the denominator. Well, if you do 3 times -2 squared plus 2 times -2 minus 8, right? That turns out to be 0. So by the factor theorem, x minus -2, which is x plus 2, is a factor of the denominator. That's really what I'm trying to say here. So for x plus 2, which is x minus -2, we get that is a factor of the denominator, okay? That's a factor of it. Because again, if you replace x by -2 in the denominator, you get 0. So it's a root of the denominator. Okay, but just like with factoring out x, we had to divide to see what's left over. We're going to do that here. What we have to do is divide to see what's left over. Now you could do polynomial long division, but it's really enough to do synthetic division. Right? X plus 2 we can think of as x minus -2. It has to be x minus something if you're going to do synthetic division. Okay? So then -2 comes here. We have the 3 over here, right? Coefficients, 2 over here, -8 over here, right? Degree 2, but we have all the what do you call it, the terms. This here, let me get the red pen. Okay. This 3 comes down, right? Remember what you do? You multiply. Okay. Remember that's what you do. You multiply, right? And then that answer, which is -6, you put up here, right? And then you add, you get -4. And basically now the process repeats itself. Here, let me actually erase those red marks. Okay, do that. Basically what's going to happen, again, this is just synthetic division. What's going to happen now is you're going to have -2 times -4, okay? That becomes 8. Look at the arrow here. -8 plus 8 becomes 0. Okay, and remember when you're dividing synthetic division, the last number here, this last number is the remainder. These are the coefficients of the quotient, which is 1 degree less than the dividend. Well, the dividend here is degree 2. So the quotient is degree 1. So we get 3x minus 4. So this factor becomes this product. This product here. Okay. And so we put it down here, the x plus 2's cancel, and you can see then that this is now simplified. No common factors. All right, good. Okay, any questions on this? Okay, this one I was going to have everyone try. Let me just double check something. Make sure I didn't send it by mistake. I don't think I did. Okay. No, I didn't. Good, good. Okay, so this one I want everyone to actually try. Okay, I just had to check in my email to see if I sent these by mistake. The solutions to these, that is. But I want everyone to actually try this out. You know, what you're gonna do is you're gonna divide and then simplify. Remember, last time I did go over division. You take the reciprocal, that is, you flip the second rational expression, and then you multiply. But again, when you multiply, you can leave it in factored form, mostly because you're going to simplify, okay? So I want everyone to try this out. Take about 5 minutes, okay? So let me stop the recording.